Welcome to AWS Academy NLP. Here's what you'll learn about in this module. The first section is a course overview. The next section provides a high-level description of natural language processing, or NLP. The third section describes business problems that can be solved with NLP. And finally, you'll review different job roles that work on NLP solutions. Okay, it's time to get started. At the end of this module, you should be able to identify course prerequisites and objectives, describe NLP, describe the business problems solved by NLP, describe the various roles that require NLP, and identify NLP tasks for each role. This section covers course prerequisites and objectives. Here's a review of the course prerequisites. First, you should already have some general IT technical knowledge. The foundational computer literacy skills you'll need to be successful include basic computer concepts, email, file management, and a good understanding of the internet. Completing the AWS Academy Machine Learning Foundations course is a requirement for taking this course. You should also have intermediate skills with Python programming. Finally, you should have a general knowledge of applied statistics. To ensure success in this course, it's preferred that you have a general familiarity with machine learning concepts, a working knowledge of distributed systems, familiarity with general networking concepts, and a working knowledge of multi-tier architectures. By the end of this course, you should be able to describe NLP, understand how to apply the ML pipeline to NLP, implement text extraction to obtain data from web pages, create a solution for a sentiment analysis business problem, use Amazon Comprehend to implement a topic modeling solution, build a solution that uses AWS services to transcribe and translate text from multimedia, and finally, build a solution using a combination of algorithms and AWS machine learning services. To achieve the course objectives, the course is divided into the following modules. This first module is an overview of the course. Module 2 introduces NLP as a domain. In Module 3, you learn about processing text with NLP. Module 4 describes how you can implement sentiment analysis. Module 5, you learn how to extract information. And Module 6 introduces topic modeling. Module 7 describes how you can work with different human languages. Finally, Module 8 summarizes the course. You'll also learn about the steps you'll need to take to prepare for certification. Module 2 introduces you to the NLP domain. Section 1 describes the relationship between NLP and the general field of machine learning, which is also known as ML. Section 2 describes common tasks in NLP. Section 3 provides a detailed explanation of an NLP problem. Finally, Section 4 is about the evolution of NLP. Module 3 provides you with an overview of how you can process text with NLP. In Section 1, you're introduced to the overall process for extracting text. In Section 2, you'll learn how to extract text from an HTML page. Section 3 reviews some common steps for pre-processing text. Section 4 examines several different ways to add tokens to text. Section 5 describes common processing steps. Section 6 reviews the guided lab on text processing. In Section 7, you learn about other steps for NLP. And finally, Section 8 covers some more advanced forms of text processing. Module 4 introduces sentiment analysis. In Section 1, you're introduced to a scenario you use in the module. Section 2 identifies the steps for processing text to analyze sentiment. Section 3 reviews common algorithms used for sentiment analysis. Finally, Section 4 reviews the challenge lab for sentiment analysis. Module 5 introduces information extraction. Section 1 provides a high-level overview of the concepts and the process for extracting information. Section 2 describes several different types of information extraction, such as extracting named entities from text. Module 6 introduces you to topic modeling. Section 1 introduces the dataset you use in the lab. Section 2 covers the overall approach that you'll take to topic modeling and outlines the specific processing steps. Section 3 introduces Amazon Comprehend. In Section 4, you learn about 3 different algorithms you can use for topic modeling. Finally, in Section 5, you learn how to make recommendations based on text. Module 7 describes how you can work with different human languages. Section 1 provides a high-level overview of the challenges of working with languages. Section 2 describes the overall process for translating text. In Section 3, you learn how to use Amazon Translate to translate text between languages. In Module 8, you work on a class project and review what you have learned in the course. Section 1 provides a high-level review of the information covered in the course. Section 2 reviews the requirements for becoming certified in machine learning and suggests some steps for moving forward to your path to certification. Thanks for watching, and in the next video, you'll get an overview of NLP. Welcome to Section 2. What is NLP? Before learning about NLP, you'll review the following example of NLP. Amazon Alexa. Here's a diagram that shows how Amazon Alexa uses NLP to create a conversation with users. First, an Amazon device, such as Echo, records your words. The recording of your speech is sent to Amazon servers where it can be analyzed more efficiently. Amazon breaks down your phrase into individual sounds. Then it connects to a database, which contains the pronunciations of various words. It finds the words that show the closest correspondence to the combination of individual sounds. Then Alexa identifies important words so it can make sense of the task and perform their corresponding functions. For example, if Alexa notices words like outside or temperature, it opens the weather app. Finally, Amazon servers send the information back to your device and Alexa speaks. NLP is a broad term for a general set of business or computational problems that you can solve with ML. NLP systems predate ML. Both speech-to-text on your old cell phone and screen readers are examples of NLP solutions. Many NLP systems now use some form of ML. Words are at the lowest layer of the hierarchy. A group of words makes a phrase. The next level up in the hierarchy is a group of phrases, which makes a sentence. And ultimately, sentences convey ideas. NLP systems face some significant challenges, which you'll learn about next. One challenge for NLP is that language isn't precise. Often the same words or phrases can have multiple meanings. As an example, consider the term weather. You might be under the weather, which means that you're sick. However, there's wonderful weather outside means that the weather conditions outside are good. Words can have different meanings, and these meanings are based on the other words that surround them. The words that surround the words are known as the context. Words can also have different meanings based on inflection. For example, the phrase, "Oh, really?" could express surprise, disagreement, or many other meanings. The meaning of the phrase depends on a combination of context and inflection. One main challenge for NLP is discovering the structure of the text. One of the first tasks of any NLP application is to break the text into meaningful units, such as words, phrases, and sentences. Another challenge is labeling data. After the system converts the text to data, the next challenge is to apply labels that represent the various parts of speech. Every language requires a different labeling scheme to match the language's grammar. Representing context is also a significant challenge because word meaning depends on context. Any NLP system needs a way to represent context. It's a big challenge because of the large number of contexts. Converting context into a form that computers can understand is difficult. Finally, another challenge is applying grammar. Although grammar defines a structure of language, the application of grammar is nearly infinite. Dealing with the variation in how humans use language is a major challenge for NLP systems. Addressing this challenge is where NLP can have such a big impact. Section 3 reviews some of the business problems you can solve with NLP. You can apply NLP to a wide range of problems. Some of the more common applications include search applications, such as Google and Bing, automated language translations, human-machine interfaces, such as Alexa, sentiment analysis for marketing or political campaigns, social research that's based on media analysis, and chatbots to mimic human speech and applications. As you learned in the AWS Academy Machine Learning Foundations course, many different roles involve working with NLP. Now you'll learn about some of the different roles that work with NLP applications. The demand for machine learning skills is growing rapidly. The machine learning roles you learned about in Machine Learning Fundamentals are also applicable to NLP. The technical skills with the highest demand for working in machine learning are Python programming, SQL data science, data mining, and data analysis. As a data scientist, you use analytical and statistical skills to collect, analyze, and interpret large data sets. When working on NLP applications, you might be asked to evaluate machine learning models to optimize outputs. For example, you could be asked to determine whether a topic modeling application is correctly classifying topics and whether classification errors are statistically significant. Data scientists acquire and prepare data. They also explore and analyze data sets to help select appropriate algorithms and models. Finally, data scientists often validate findings and present recommendations to stakeholders. Machine learning engineers need some skills that are similar to a data scientist's skills. However, as an engineer, your focus is more on programming skills and software architecture. As a machine learning engineer, you will apply those skills to design and develop machine learning systems. A machine learning engineer working on an NLP application would be more involved in designing and implementing the end-to-end solution for the NLP problem. You might decide to work toward a career in science where you can apply ML technology to an NLP application. ML has impacted many science fields, from astronomy to zoology. So many different paths are open to you. As an applied science researcher, your primary focus is the type of science that you concentrate on. As an example, an applied science engineer might use ML to develop an NLP application that processes a large volume of medical histories to look for patterns of misdiagnosis. Applied science researchers can be from many different disciplines. The tasks they perform are specific to their particular domain of expertise. For example, a biology researcher might use NLP tools to analyze findings from a collection of lab summaries. Many software developers are now adding NLP functionality to their applications. For example, it's now more common to encounter voice interfaces and text analysis that's based on ML. As an ML developer who's focused on NLP, your primary focus is on software development skills, but you also need some skills of a data scientist and ML engineer. As a software developer who works with NLP solutions, you're more likely to develop code that interfaces directly with an ML service, such as Amazon Comprehend. NLP developers often rely on either a data scientist or an ML engineer for their expertise with identifying and optimizing appropriate data sources and models. In this educator-led activity, you'll be challenged to find a job description for an NLP role that you're interested in working in the future. You can search on popular job posting sites such as Indeed, Glassdoor, or Monster.com, or other sites that you know of. Be prepared to share your findings with the class. Thanks for completing this module. In the next module, you'll learn about a common approach for working on NLP applications.
Hi, and welcome to Module 2, an Introduction to Natural Language Processing, or NLP. Here's what you'll learn about in this module. In the first section, you'll learn about how the machine learning pipeline, or ML pipeline, changes for NLP problems. The next section provides a summary of some common NLP tasks you'll perform in the course. The third section walks through a typical NLP problem. And finally, you'll learn about the history of NLP and how ML and deep learning have improved NLP capabilities. Okay, it's time to get started. At the end of this module, you should be able to describe how the ML pipeline can be applied to NLP. You should be able to identify common NLP tasks. Use the ML pipeline on an NLP problem. And summarize NLP architectures. This section covers NLP and machine learning. You can apply the same ML pipeline you learned about in AWS Academy Machine Learning Foundations to NLP problems. In this section, you'll review each stage of the pipeline and learn some of the key differences for working on NLP solutions. The first task for all ML problems is to formulate the problem. In this stage, you'll make sure that the problem is actually an NLP problem and that you have a suitable data set to address the problem. You should also work with business stakeholders to get a clear definition of success metrics and brainstorm on the simplest way to solve the problem. The next step is to collect data. Data for NLP can come from databases or earlier systems, documentation, or websites. Data can be simply text or a combination of text and other data types. Collecting NLP data from databases or earlier systems isn't any different than collecting regular data. You can collect, ingest, and transform data from multiple systems into a single location using AWS services like AWS Glue. You can also use techniques for extracting, transforming, and loading data, which is known as ETL. Sometimes you'll work with paper documents, either handwritten or typed. These documents will need scanning. And with handwritten text, you might also need to use ML to identify the letters and symbols. For audio and video, you might need to transcribe the speech with a service such as Amazon Transcribe. If the data is in different or multiple languages, you might need to translate it before you do any further processing. One thing to be aware of is that the text data often won't be labeled for working with ML models. As such, you'll use more unsupervised models in your NLP solutions. When you evaluate data, you'll need to analyze the text elements to identify characteristics that might impact your solution. The following list isn't exhaustive, but some of the most important things you need to determine are: what languages are in the data? Languages have many differences that impact the process. For example, many European languages are structured differently than many Asian languages. Having a consistent language will help you solve problems with a higher degree of accuracy. Next, you'll need to consider the writing style. Is the text a formal scientific journal, a blog post, or a social media post? The writing style can impact how you process your data. For example, when you work with social media posts, you'll need to decide how to deal with emojis, sarcasm, and slang. You might also need to expand acronyms depending on your scenario. Another aspect to consider is whether your data has incorrect spelling. Having the correct spelling will improve results. You'll also need to determine how to handle special characters. You might need to remove or convert special characters to process the data correctly, such as emojis, punctuation, and mathematical symbols or formulas. For example, a thumbs up emoji and the word great might express the same meaning in your problem domain. Next, you should consider domain-specific terms. It's important to understand what terms you have and how they might impact the results. For example, a common task is removing stop words, such as the, and, do, or don't. However, removing these words can cause problems in sentiment analysis, where do and don't could change the sentiment of a statement. Finally, you should consider word forms. You'll need to decide whether to convert different forms of a word to a common format. This process could be converting forms of the same word into a common format, such as converting run, runner, and running into run. It could also be more sophisticated, converting similar words into a standard word. For example, good, great, brilliant, and better could all be represented as good. After you evaluate the data, you'll need to perform some processing to extract the features you need. First, you'll need to process the text. Here are some of the tasks you'll perform in processing. Normalization. This includes several text processing steps, from converting text to lowercase to removing punctuation. You'll learn about many of these steps in the next module. But for now, you can think of normalization as cleaning up the text to make it consistent across your data. Stemming. This is a method for changing different forms of a word into a standard form. For example, you might change run, runner, and running into run. Lemmatization is another technique. It converts similar words such as good, great, and better into a single common word, like good. After you process your data, the final step is converting the text into numeric values. You can do this in different ways, depending on the problem you're trying to solve. You'll learn about many of these techniques throughout this course. But for now, you can imagine that each word in the text is converted to a column of numbers. It's worth mentioning here that you'll often end up with data sets that contain hundreds of columns. After you've defined your data set, the process is the same as the regular ML pipeline. You'll split the data into multiple sets for training, testing, and validation. Next, you'll select and train a model. You'll assess the model against the business goal by using the metrics provided by the algorithm, or by calculating your own. You might then tune the model by updating the model's hyperparameters, or by changing how you process the data. You'll then repeat this process many times and use the metrics to find the best performing model. It's important to determine if the solution meets the business goal. Using metrics can be a good way to determine this, but you need to understand which metrics to use, which depend on your goal. You'll learn about this process in more detail when you go through the walkthrough that's in the next section. Finally, you'll deploy, monitor, and maintain your model. Amazon SageMaker has features that make this process easier to manage, but these features are beyond the scope of this course. Thanks for watching. In the next video, you'll Hi, and welcome to Section 2, Common NLP Tasks. In this section, you'll learn about some of the more common NLP tasks. Specifically, you'll learn how to process text to get it ready for training in an ML model. The first step is collecting the data you need to solve the business problem. Like most ML problems, the data won't be in the correct format, and you'll need to gather data from multiple sources. These sources can include traditional databases in earlier systems, but the data could also be in handwritten documents or be embedded in a web page among advertisements. There are some Python tools that can help you extract data, like Beautiful Soup and Scrappy. AWS also has a service called Amazon Textract that extracts data from documents. You might also need to translate text or transcribe audio to get the data you need. The target data format is typically a text document that you can further manipulate with text processing. You'll need to complete several tasks to process your text. The specific tasks depend on the scenario and the state of your data. In the next few slides, you'll learn more about some of these tasks. This example shows the text you want to process. In this task, the stop words were removed. This process removes words such as is, an, and and. Sometimes you want to remove all stop words or only a subset of stop words. It will depend on the scenario. For example, the word not can change the sentiment of a statement, so you might want to keep it depending on your business goal. A set of normalization steps is next. Here's what happens in this step. First, the text was converted to lowercase. Next, the acronym NLP was expanded to Natural Language Processing. The letter B and the numeral 4 were converted to the word before. Next, the punctuation was removed. And finally, the spelling of the misspelled word spelling was corrected. In this step, stemming was used to convert words to a common format. In this case, for example, pre-processing was changed to pre-process. Similarly, processing was changed to process. Training was changed to train. Spelling was changed to spell. Converting was changed to convert. And words was changed to word. Notice that the word removing was converted to remove without an E at the end. This change isn't a spelling error. In fact, it's a common way to stem words like this example. In this step, lemmatization was performed. That is, step was converted to task, and better was converted to good. Here's the final result of these steps. You might think some of these steps don't make much of a difference in this example. But when the same steps are performed across the entire corpus of text, you'll usually get better results because these processing steps introduce consistency. The final task is converting the text into numerical values. The diagram shows a simple example where the text was converted into numerical values by using a vectorizer. You'll learn about this more in the walkthrough and in later modules. Thanks for watching. In the next video, you'll walk through an example of applying the ML pipeline to an NLP problem.